Hello everyone, welcome to this video. Today we will solve few problems which were asked in GATE exam. This is the first problem. Limit x tends to 0, 1 minus cos x upon x square. To solve this problem, let us first simplify the numerator by using trigonometric formula. For 1 we can write sin square x plus cos square x. And cos a plus b formula for, let us write formula for cos 2x. Cos 2x can be written as cos 2x is equal to cos of x plus x. Apply here a plus b formula. Here value of a and b are same, x and x. This is equal to cos a cos b minus sin a sin b. As a and b are same, that is x cos x minus sin x. Here cos x minus sin x sin x. See, we are deriving formula for 1 minus cos 2x. Okay, standard formula. Then sin square x plus cos square x minus cos x cos square x minus plus sin square x. This plus cos square x and minus sin cos square x will get cancelled, and here we get 2 sin square x. See, for 1 minus cos 2x we are getting 2 sin square x. If the angle is 2x, then we are getting x. If the angle is x, then we will get x by 2. Therefore, this can be written as limit x tends to 0. 1 minus cos x can be written as 2 sin square x by 2. Here angle is x by 2 divided by x square. Now, let's take this 2 constant outside the limit. Limit x tends to 0 sine of x by 2. Let us adjust this denominator x by 2. Let us multiply by 2 in the denominator, multiply and divide by 2 in the denominator. Okay, and what we can write here, square sin square x by 2, that term we already have here. This 2 will get cancelled and ultimately we will get x square only. Okay, if we take this 2 outside, what we are supposed to write, it is 2 square means 4, and this entire bracket limit x tends to 0 sin x by 2 upon x by 2 square. This entire thing is limit theta by theta, limit sin theta by theta, theta tends to 0 is 1. Therefore, the final answer is 1 by 2. This can be solved by using L'Hospital rule also. L'Hospital rule. As here this is indeterminate form. If you put the value of x 0 here, cos 0 is 1, 1 minus 0, 1 is 0 divided by 0. Therefore, in this case, while using L'Hospital rule, we have to differentiate numerator as well as denominator. Therefore, limit L is equal to limit x tends to 0, derivative of numerator is 0, minus cos x derivatives plus sin x upon x square derivative is 2x. This is sin x upon 2x. Once again, if we put the value of x 0 in this expression, what we get? Sine 0 is 0, 2 into 0 is 0, again 0 by 0 indeterminate form. Once again differentiate this expression with respect to x. What we get? Limit x tends to 0, derivative of sin x is cos x upon derivative of 2x is 2. Now put the value of x here. Cos 0 is 1 divided by 2. This is the answer. We are getting same answer. Next problem is the inverse Laplace of the function f of x is equal to 1 upon s into s plus 1 is. To find inverse Laplace of this function, we are supposed to find partial fractions for this expression first. What is function? 1 upon s into s plus 1. This can be written as some constant a upon s plus first factor plus some another constant b upon second factor s plus 1. This partial fraction is in the form of denominator contains non-repeated linear factors. Both the factors s and s plus 1 are linear factors. Now let's solve this equation for a and b. What we get? 1 is equal to a into s plus 1. If you take this denominator to right side, we get here a into s plus 1 plus b into s. Now to get a and b, either we have to vanish a or b by putting suitable values of s. Now let us put value of s here. S is equal to, put s is equal to minus 1. What we get? 1 is equal to a into minus 1 plus 1, 0. This entire thing will become 0. 0 plus b into minus 1. This implies minus b is equal to, or what we can write, 1 is equal to minus b. This implies b is equal to minus 1. Now to get value of a, let us put s is equal to 0 in this equation. We get a is equal, 1 is equal to a into 0 plus 1, it is 1, plus b into 0, it is 0. Therefore value of a is 1. Now let us substitute values of this a and b here. The function is f of s is equal to 1 upon s into s plus 1 is equal to a upon s. Value of a is 1 upon s plus value of b is minus 1 upon s plus 1. Just we have substituted values of a and b in this equation. This is equal to 1 by s minus 1 by s plus 1. This is our function. Now to find inverse Laplace, Laplace inverse of this function is equal to Laplace inverse of 1 by s minus 1 by s plus 1 equal to Laplace inverse of 1 by s minus Laplace inverse of 1 by s plus 1. Laplace inverse of 1 by s is 1. Laplace inverse of 1 by s plus 1 is e raised to minus t. This is the answer. Next problem. The parabolic arc y is equal to root x, 1 less than or equal to x and x less than or equal to 2 is revolved around the x-axis. The volume of solid of revolution is, we have to find the volume of solid of revolution for this given function. The solid generated by revolution about x-axis bounded by the function between the limits a and b is given by volume of solid of revolution. V is equal to a to b, these are the limits, pi y square dx. This is the formula for volume of solid of revolution. Here the value of function given here is y is equal to root x pi, and the limits are 1 to 2. The limits of x variable are 1 to 2. Y square means root x whole square dx, pi into integral of x dx between the limits 1 to 2 equal to pi. Integral of x is x square by 2, x square by 2, limits 1 to 2, pi by 2. You can take this 2 outside. 2 first put upper limit 2 square minus, then put lower limit 1 square, pi by 2 into 4 minus 1, that is 3 pi by 2 is the answer. This is the volume of solid of revolution. Next problem is the value of the integral minus infinity to plus infinity dx upon 1 plus x square is. Very simple problem. As we know, the integral of 1 upon 1 plus x square is tan inverse x. Minus infinity to plus infinity dx upon 1 plus x square is equal to tan inverse x. Limits are minus infinity to plus infinity. Tan inverse of, first put upper limit infinity minus tan inverse of minus infinity. No need of bracket. Tan inverse infinity is pi by 2 and tan inverse minus infinity is minus pi by 2. Therefore, the final answer is pi. Pi by 2 plus pi by 2 is pi. Next problem is the modulus of the complex number 3 plus 4i upon 1 minus 2i is. We are asked to find modulus of this given complex number. Therefore, first of all, we need to find the real and imaginary parts of this complex number, that is x plus iy. X is a real part of complex number and y is the imaginary part of complex number. Let us simplify this complex number to put this in x plus iy form. 3 plus 4i upon 1 minus 2i is equal to convert this into x plus iy form, let us multiply this complex number by complex conjugate of denominator. 3 plus 4i upon 1 minus 2i into complex conjugate of this denominator is 1 plus 2i upon 1 plus 2i. Multiply by complex conjugate of denominator to numerator as well as denominator. Now multiply these two brackets, what we get, 3 plus 6i plus 4i plus 8i square upon 1 plus 2i minus 2i minus 4i square. As I is imaginary number, root minus 1, complex number, therefore this implies I square is equal to minus 1. 3 plus 6i plus 4i, what we get, 10 I, and 8 I square is minus 1, 8 into minus 1 minus 8 upon 2I plus 2I minus 2I will get cancelled. I square is minus 1, 4 into minus 1 minus 4, and this minus it will become plus 1 plus 4. In the denominator we get 5. Therefore this will be 3 minus 8 is minus 5 plus 10I upon 5 minus 5 by 5 plus 10 by 5 I minus 1 plus 2 I. Here real and imaginary parts we can write. This is real part x, this is imaginary part y. Therefore here value of real part is minus 1, value of imaginary part is 2. Therefore modulus is, the formula for modulus is root of x square plus y square, root of value of x is minus 1 whole square plus 2 square, it is root 5. This is the answer. Thanks for watching. I will see you in the next video. Till then, goodbye.